Where's Ian disappeared? Good, but we are live. Welcome everyone. Hello. Thanks for joining. I'm really looking for the next very interesting talk. And this talk got a lot of, or the situation, it's a real life situation, got a real big amount of media coverage in the last month. So looking forward to hear the details, right? But first of all, I want to introduce the speakers, Ian, Tabor and Ken Tindell. So Ian is an automotive consultant. He is very active in the car hacking village topic. So he runs the car hacking village in UK, and he is part of the car hacking village DEFCON, and also Ken is very known in the community. He's the CTO of Canis Labs. He obtained a doctorate in real-time systems from the University of York. You probably know him about all things Ken, right? And this is the man who has his own law, the Tyndall's first law of automotive, right? It's always the infotainment, and if it's not the infotainment, then it's the wiring. So let's see how it plays out in the session here. I was informed that this session is pre-recorded and will be played out. However, Ian and Ken will be there all the time, and at the end we have the 10 minutes for your question. And if this is not enough, we will still have the possibility to ask them all the nitty-gritty questions in our launch stage one launch with the speakers. So let me just play their video, and then we unhide ourselves for the time being. So play the video.
Good afternoon. Welcome to Ken and my talk on how an automotive security researcher had his car stolen by a CAN injection. That's the official version of the title. The alternative version is the irony of how an automotive security researcher had his car stolen via a method he found on another vehicle. Just going to hand you off to Ken to introduce himself.
My name is Dr. Ken Tindell, and I am what Ian calls his CAN bus guru. I'm a car industry veteran, started in 1995 with the Volvo S80 when CAN was a shiny new thing. And I helped Motorola design their first real-time CAN controller, and I sold my startup to Bosch. Today I'm the CTO of Canis Labs. We're a CAN bus security company aimed at the car industry. Do some hardware IP design, and do some embedded real-time software. So CryptoCAN is our software layer for encrypting CAN frames. And I'm a member of the CIA, that's CAN in Automation, CANSEC working group for CAN XL security.
So who am I? I'm Ian Tabor, or Mintinet. You could say I'm the ultimate car hacker. Built this kit car 18 years ago now. If you want some more details, see my website. There's a little disclaimer down the bottom there. This work was completed within my own time and budget and had nothing to do with any current or previous employers. So where did I start? In 2015, I bought this Citroen DS5. In a head unit, you could tether to your mobile phone and surf the internet. If you did that and did an Nmap scan back in the other direction, you found 4 ports available: 23.111, 3333, and 20,000. Everyone knows Telnet. If you Telnet to the head unit, you had full root access with no credentials, no nothing, which meant you could extricate any of the PII data inside the head unit, either using USB or FTP. I then wrote up my findings in 2017 and sent them over to Peugeot Citroën, and pointed out, is it not a matter of French national security because the French president gets driven around in one of these? Their comment was, meh, didn't really care. The eventual fix was to disable the Wi-Fi. Strange, you could actually do the same hack over Bluetooth and re-enable it using some of the SQL-like databases that were internal on the actual head unit itself. Here is one of my most treasured tweets from Charlie Miller himself, saying cool findings. So in August 2018, I spoke at DEF CON Car Hacking Village regarding those DS5 findings and the process of trying to find someone to disclose to and all of the fun that came with that. On to September 2018, I was one of 12 global researchers invited by Bug Crowd to a bug bash over in Louisville, Kentucky. When we first got there, I noticed the vehicles had radar-guided cruise control. That is the sensor there. If you look close enough, there's a sort of black plastic shroud over the sensor. If you pull the shroud off, undo 2 bolts, and pull the sensor out, it gives you access to the wiring at the top. Unplug the sensor. That CAN bus has full access to start, stop the vehicle, unlock, lock, open the trunk, etc. Between Spectres, RQ and myself, we got a 5-figure payout. Here is a picture of a slightly slimmer younger me going, watch this, tappy tappy tap, start the vehicle. So, yep. After that payout, I built myself a car in a box called PD0. It's most of the electronics from a Peugeot 208. P for Peugeot, D0 is 208 in hex. And then January 19, I started the Car Hacking Village in the UK. This car in a box actually thinks it's a fully working car. On the left-hand side, there is an ABS simulator. There's a crank and cam simulator, O2 simulator. On the right-hand side, you can see the head unit in a box. That is still vulnerable to the Wi-Fi and Bluetooth hack if anyone wants to have a play. I've taken it to numerous conferences across the UK, one in Europe, and I've been requested to take it globally, but logistically it would be a nightmare. So in 2019, I was again invited back to the Bug Bash at the OEM headquarters in Detroit, one of 20. I did Radar Hack version 2. That device there on the blue box is basically an ESP32, which has Bluetooth, Wi-Fi, and an infrared receiver. And basically, you can plug that in between the radar and the rest of the vehicle and stand over the other side of the car park, press a button on the infrared remote control, and mysteriously the trunk would open. And again, mysteriously, the engine would start. Yes, it's a targeted hack, but we wasn't actually allowed to try and do a test on a moving vehicle, but I believe potentially we could have full control of the vehicle over the Bluetooth CAN adapter that was included. In October 2019, I was also part of a group of 3 of us that went to the Auto Isaac Summit in so it was US HQ for HackerOne, where we spoke about vulnerability disclosure program and how it's good for the automotive industry, how actually engaging with researchers, etc., like myself, will help find and fix issues. That was with Spectres and Motley. So in 2020, or COVID years, I built Value Pasta Auto. This is a cheaper alternative to Toyota's Pasta. Toyota's Pasta version costs $30,000, which basically is a car. My version is based on teensy microcontrollers and Arduino software and cost me about $800. Again, more details on my website and other videos I've posted in the past. I have actually retrofitted this with an RFID ignition key, and it is also vulnerable to the JBL speaker device. So you could plug in the JBL speaker device, force ignition on, like you would on a real vehicle. Lead up to the theft. In April 2022, I came out on a Sunday morning, found my bumper hanging off, headlight unplugged, wheel arch trim hanging off. It was on the curbside, so it couldn't have been an accident. So that was me thinking it's vandals. Didn't think anything of it until a couple of days later. Another security professional in the automotive industry got in contact and said, by the way, they may be trying to steal it. You may want to do something about that. So I purchased a dash cam front and rear, fitted it. It wasn't actually on permanent power. So in July, second day into my new job, out at 6 o'clock in the morning, again, bumper hanging off, headlight unplugged. Had to drive to work with only one headlight. Got into work, put it all back together again. My dash cam didn't pick it up because for some stupid reason they're not default configured to pick up stuff when the vehicle is off. They're only default to pick up stuff when the vehicle is on. So I enabled it at that point. That evening, came home. Wednesday, everything was okay until I went to bed. Early hours of Wednesday morning, got a nudge from the missus. Where did you park last night? Where I normally park. Why? The car's missing. Oh, bugger. As you can see from my tweet, it was more than oh, bugger. So what did I do at that point? I got onto the My Toyota app on my phone. As you can see there, it's got 100% fuel, 11,000 something miles. And if you read down the bottom by the icons at the bottom where it says find my car, it says vehicle in movement. Yep, in the UK, Toyota doesn't have stolen vehicle tracking, and it won't track a vehicle while it's in movement because of reasons. For example, domestic violence situation. So if you were trying to get away from someone, you wouldn't want them to be able to real-time track you. It only then updates the location when you get to your endpoint. The strange thing is, if you look at the next part of the My Toyota app, if you look there, the fuel gauge is now down at 50%, which means it's probably been about 150 odd miles. Again, it says vehicle in movement. I'm not going to dox myself because I don't actually live there anymore, but where did it update the location when it updated the fuel? Because it must have updated something somewhere. Finally, in the My Toyota app, there's your notifications, and at the top there are two notifications at 2:05 in the morning. Warning detected, hybrid system, high severity, please have your car inspected at a dealer. And again, warning detected, sonar system, please have your car inspected at a dealer. I actually spoke to a friend that works in Toyota, and there were also another 24-ish other diagnostic trouble codes set by the vehicle at the point in which it was stolen. So yes, I believe they must have either cut any GPS connectivity, because I never saw the car again. Was it a targeted hack? Ken thought it was, because yep, he's the one that did the radar hack. Ironically, I did check to see whether the radar hack was possible on the RAV4. It is not, because it's on a separate network. However, a few weeks later, my neighbour had a 2021 Land Cruiser. Yep, had a 2021 Land Cruiser. First time they tried to nick it, the alarm went off and the three little scrotes run off. A few weeks after that, he left his vehicle out on the roadside for about 20 minutes, half hour one evening. He went in, he came out, it was no longer there. So it wasn't a targeted hack, and there are numerous locations of RAV4s around the area where I used to live that they weren't there anymore. So I believe it was a bit of a crime spree. Looking on Reddit and other social media platforms, there were other areas around London, North London, Essex, where RAV4s and Lexuses were also being targeted. So my initial investigations, I came across this tweet on Twitter. If you look, it's slightly sped up. So pull the bumper away. Mate comes in with a torch. Let's find the headlight wiring. Oh look, lights are on. Oh look, it's already unlocked and they're already away. That video there was about 90 seconds, 2 minutes in total, slightly sped up, but you can see how easy it is. So more investigation. I spoke to a friend of mine who does vehicle system forensics. He used to be an ex-traffic cop. He told me about some devices that his ex-colleagues had found that looked like JBL speakers and may or may not be sold as emergency start devices. Why a locksmith needs to have something that's hidden as a JBL speaker, I have no idea, but you can guess why the criminal needs it, because it's plausible deniability. Basically, if they get stopped in the street, it's a Bluetooth speaker that may or may not work. The only way you can tell it is actually does what it can do is the cable that comes with it is USB-C to 2 pins. I'll show you that in a second. When I initially found out about this device, it was €1,500. When I actually decided to purchase it in February this year, it ended up being €2,500. I'm not going to be giving any details of the actual website itself, A, because they no longer sell it and you cannot get it from them, but B, because I don't want to be advertising services of the theft devices. This is a list of claimed vehicles it says it works on. As you can see, Supra, Prius, CHR, RAV4, Highlander, Land Cruiser, Price, and most of the entire Lexus range. I've not tested them all, but I've seen videos that sort of attest to most of them. On to the next slide, the actual theft device itself. Here is an external picture, little JBL speaker. There is the USB-C cable I mentioned earlier. 2 pins on one end that uses D plus D minus to get CAN high, CAN low out. There is the inside of the device. That big black plastic, big black resin blob covers up all the electronics. Inside those electronics is a PIC 18F25K80 and a modified CAN transceiver. Ken will be going into some details in how that works in a second. We did try a bit of firmware reverse engineering, but there's no honor amongst thieves. As you can see, code protection is enabled on most of the write blocks. There is potentially a way to get this data out, but it would require buying 2 of these devices. And as these devices are now €4,500 each, I'm not buying a second one, and I don't believe I need to, because we've managed to get the data out of it from just analyzing the CAN traffic that it generates.
Okay, let's look at some bench testing of how we looked at what was going on in the device. First thing to say is this is fake data. So none of the IDs or payloads or anything are actually what the real device was doing. So we synthesized a replica device and then changed all the data, because we're not here to help people make theft devices. Okay, so a couple of things to look at on this chart here. So this is sending an ordinary CAN frame from an ECU. And you can see how this is all behaving perfectly fine. So this is the digital line, is the start of frame edge, payload, CRC, and then the end of frame fields. And you can see the CAN analog traces here, high and low, and you can see when there's a dominant bit here, the 2 voltages are pulled apart by the transceiver, and then when it goes back to recessive, the lines float back to their normal levels. So that's how CAN works. You pull the voltages apart to signal a dominant bit, level 0. Okay, let's have a look what happens when this is switched on. This is the injection chip select. This turns on the recessive or dominant override, the recessive generation from this fake transceiver. So it's now sending a single level, which is a recessive bit, and that is being forced onto the bus. So here is our ECU trying to transmit as before, so it's sending along, and now it's trying to pull a dominant state, but you can see the dominant state is not actually being pulled onto the bus, because the transceiver of this ECU is being overpowered, and it gives rise to this very strange bit pattern here on the ECU side, and that's explained. That's in a CAN quiz question on my blog, exactly why this happens. But basically, this is the CAN error handling protocol when someone is driving the bus recessive, and the device can't signal a dominant bit. So you can see here we're going to drive the transceiver on in its override mode, and we're going to inject. Here you can see it injecting its own CAN frame on the bus. So these other ECUs here have no chance to signal any kind of error frames or anything. They have to take what this is seen. If they try and signal an error, it gets overridden by this particular signal on the bus. Now, normally that would be a problem with CAN, because CAN requires the acknowledge bit place. But these ECUs are actually receiving acknowledge, and the reason is, even though one ECU cannot send a dominant bit on the bus and overpower the transceiver, when they all collect together and they all drive the bus with their transceivers, that is enough to actually force the bus into a dominant state. So if you're transmitting and there's only one other ECU on the bus, it can't send the acknowledge bit. But because there are multiple ECUs on the bus, that acknowledged dominant bit does get sent, and the frame gets accepted and received at all the ECUs as normal. So basically, this device can force its own CAN frame onto the bus. It can overwrite everyone else's data, and no one can signal an error, and then they would all accept this frame as valid. So it's a custom transceiver circuit. We're not going to describe how that works. It isn't a proper CAN transceiver, of course, because criminals don't have to care about compliance with ISO 11898. And the important message here is that it can push any traffic on the bus, and it can't be stopped. So all the hardware security approaches, like the NXP Stinger transceiver and CAN HG, can't stop these spoof frames because they can't inject an error frame to kill a spoof frame that they've detected. Here is a very simplified version of the Toyota RAV4 CAN bus. This is showing 3 CAN buses here. And the important part is this left headlight. Obviously, there's a right-hand headlight on the same bus. And then there's the smart key ECU that talks to the driver's keys, a gateway device. So the smart key will talk through the gateway to the engine control to turn off the immobilizer. And the same is with the doors. That's directly on this CAN bus. So if you can spoof frames onto this CAN bus, you can make the gateway send them off to the engine, and you can make any other ECU accept them as valid. And that would be the door module here. I have to say this is a very simplified diagram. There's actually considerably more devices on this that won't fit on the slide, and the actual topology is much more complicated, but this is for explanation, this is a simplified version. If you check out the blog post, that's the QR code for a link to it there. The write-up has been very well received, and it's the definition used for the CVE vulnerability report. And it's generated lots and lots and lots and lots of comments. And so I wanted to go through some FAQs, or rather not FAQs, because most of the comments were in fact car security mansplanations, with all kinds of people telling us how Toyota should actually be building their car. So number 3 in the top 3 list of car security mansplanations is just add a firewall to isolate the headlights. Now, a firewall costs money. It's a PCB, it's got power, it's got case, it's got connectors. You'll have to have 2 CAN buses, 2 sets of connectors. And even if it costs just $10, which it won't, multiply that by 50 million cars, and that's cost you $500 million, which is genius vision. You're as smart as Elon Musk. Brilliant. Number 2 in the mansplanation list is just use TLS and Wireguard to encrypt all the messages. Well, CAN messages are 8 bytes long. They contain very small sensor and actuator data, like turn the main beam on and things like that. So this isn't something that's seen in mainstream computing, so those solutions are not appropriate. Because car electronics is, and I've put this here in red, this is really important, it's a distributed, hard real-time, embedded, safety-critical mechatronics system, and it controls the wheels. It's not a phone on wheels. So it's all about short, worst-case latencies and not bandwidth. You know, it's not a data center on wheels. We're not sending huge amounts of data back and forth. We're sending very, very many small sensor and actuator readings and data. And the number 1 in the list that we got was just use a relay to turn the headlights on. Well, it's not called a headlight cluster for nothing. It's got things like the main beam. There's low beam, there are side lights, there are indicator lights, there's daylight running lights. There's also different lighting modes. There's the washer pump motor, the wiper motors for the headlight. to keep it clean. And then more modern systems have are LED projector lights, so they have a grid of LEDs, and then a smart camera that's monitoring the forward-looking road is going to see oncoming pedestrians and cyclists and cars, and then change the beam pattern. And then there are all kinds of multiple ECUs that control all these features. So a relay is just not working. But it's a superlative suggestion, and one that we'll bear in mind.
Here is a sample of the reports around the globe after our blog post was released. Headlight hacking is quite a common theme. There are quite a few interesting stories, though, amongst this. In Sweden, the back end of last year, there was a load of RAV4s and RX450Hs found at a container warehouse that were allegedly stolen for payment for drugs. At the time, they thought it was done via a relay attack on the keys. However, after our research, they've subsequently had a bit of a further look, and they found out that it was actually done by CAN injection, which is good. Our research has helped sort of tidy up those crimes. Another interesting article was that the head or chairman of the AA in the UK, Sir Edmund King, had his wife's Lexus stolen. At the time, he released an article saying, please put your keys in a Faraday bag, even better, put it in the microwave. At the time, he did say that his keys were in the Faraday bag. So how did they get away with his vehicle? Actually, probably did it via CAN injection. I did send over the details to him to have a read. They were slightly busy with the managed motorway stuff. Onto another bit of media coverage. Vice.com did this video, so check the door, plug the device in. It's already plugged into the headlamp. It's now sending some messages to disable the immobilizer. However, it's not unlocked the door yet, so go back to the device, press the play button on the side. That then unlocks the door. Now you can unplug the device because it's done all its magic. Walk round to the driver's side, open the door, get in, put your foot on the brake, press the start-stop button, and if you look at the top there, the vehicle is now working, and the rest are about 1,000 idling away. Again, that took about 90 seconds to do, so yes, great, wonderful. Onto industry coverage. Upstream's first half of 2023 Auto Cyber Trend Report was released recently, with a section about our research itself. New car theft method puts headlights in the spotlight. CAN injection's been around for years. It just seems like it's a bit more prevalent lately because the thieves have now weaponized it with the JBL device itself. C2A also then released this article on the right, CAN injection, a rising threat to auto security. It's good to be recognized by the industry itself. Onto the CVE. We got the CVE issued to warn other OEMs. The CVE is 2023-29389. It was issued by ASRG. When we logged the CVE, we did actually try and get the title issued with the emojis included. There is the English spec emojis because we drive on the correct side of the road. There is the American spec emojis because you drive on the wrong side of the road. Currently, it's only listed against the 2021 RAV4, which is my car itself. Hopefully that should be updated in the future with other vehicles when we confirm which vehicles actually are affected. Actual numbers itself, as you can see, RAV4 in the last 6 years, about 5 million, Prius, 500,000, CHR, 4 million, Land Cruiser, 100,000, Highlander, about 2 million. Lexus, I couldn't find the details of the individual vehicles themselves, but as a whole, they sold about 4.2 million vehicles in that time. So potentially across the globe, there's 15.5-ish million vehicles. Okay, it's a targeted attack on a single vehicle, but it's still a big number that need to be fixed. Going back to the numbers earlier that Ken mentioned of 50 million vehicles, well, Toyota actually created in the last 6 years 56 million, times up by $10 for the firewall. That's still $500 million, if not more. Onto vehicle access. A friend of mine actually has a NX300H. I went over to go and test it using my replica device on his vehicle without the additional CAN transceiver enabled. We could unlock his car, but we could not start it. After I left and went home, curiosity got the better of him, and he then tested the device with the additional transceiver connected. He then tried it in his car park. It worked with the doors. It worked with start. He then drove the car around the car park a couple of times, put it back in his car parking space, put it all back together, and mysteriously his active headlight stopped working on the left-hand side. So a few days later, he had to take it back to the Lexus dealer and ask them to have it reset. They did reset it for him for nothing. I didn't ask him to do that, but thank you very much for doing it. What we really need to do is actually have full access to Toyota diagnostic tools to reset any DTCs and test against all the different models that are claimed to be used. Yes, that would be nice. Onto the disclosure process. Before we published the blog post in April, I did put a tweet out to see whether there were any contacts available regarding security in Toyota, because I had this device and we were reverse engineering. Nothing came back. I then thought about let's try the local Toyota dealer. So I rang up the local Toyota dealer and said, by the way, have you had any issues of cars being stolen? And the receptionist said, well, I don't think I know about that, but what I'll do is I'll get the service manager to give you a ring back. Service manager gave me a ring back, and he then explained that he had a demonstrator. He went out for dinner one night, locked it up, went in, came out the next morning, vehicle was gone. So he did a bit of investigating and found out that there was an issue with it being stolen via the headlight, etc., etc. He then told me that at one point that there was up to 3 a week being either stolen or attempted stolen just in his dealer alone. There was a memo sent out from Toyota somewhere saying, by the way, make sure you lock up your vehicles because this is happening across the country and in certain areas. I did send over to him my findings, and he then passed it on. A few days later, I got a direct email from Toyota Japan explaining that I need to report my findings via HackerOne's vulnerability disclosure program. I would do that, but there are a few restrictions on there, one of which is to modifications to the vehicle. Tell the criminal that you're not allowed to break my vehicle to steal it, but yeah, okay. And also within HackerOne terms and conditions, there is an implied NDA. That NDA basically says as soon as you report it to HackerOne, to Toyota, you then cannot talk about it to anyone else, which can't really do because these devices are available for most manufacturers on the market at this time. So we decided to reply back and say, by the way, we agreed to those terms and conditions. They came back and said, we will waive those terms and conditions. At the time, I did not agree to that, so we have not put it through HackerOne. We have been trying to disclose via ASRG. They were getting exactly the same response from Toyota. Please do it via HackerOne. Over the last weekend, I actually met a couple of people from Toyota USA, and I completely understand why they want it disclosed via HackerOne so they can log it in a position. So it's not just random emails going back and forwards. I have said to them, if they put something in writing on a proper piece of paper, we will then disclose that information to them via HackerOne as requested, and we will work with them to try and get a fix to this issue. And we understand that there may need to be some NDAs in the direction of Toyota to us so that they can inform us what they're working on and what they're doing. Yes, that will happen in the future.
Okay, let's look at a few potential fixes for the CAN injection attack. First solution is a quick and dirty short-term fix. And that's to make the gateway paranoid about CAN bus errors. It can see errors in its CAN controller, and the attack at the moment generates a whole load of errors when it's trying to push its frames over the top of genuine frames. And so the gateway could be paranoid. So on startup, if it sees CAN errors, it could say, right, I'm not forwarding any CAN frames over. Now, the theft device vendors could work around this. There are workaround techniques for that, but I'm not going to tell you about them because that's not our job to help theft device vendors to make new kit. A permanent fix to this is to use cryptographic messaging. So use solutions like CryptoCAN, which I talked about last year at this conference, or SecOC to secure immobilizer messages using authentication against spoofing. Now, there's no need to encrypt everything because only a couple of messages are needed here to be protected against CAN injection. So the overheads of this are not particularly high. It can be done in software, and you can implement a firmware fix to that. We've just started to hear about a third potential fix from Toyota. It seems that the fix involves putting a metal plate around where the headlight connector is to make it difficult for thieves to connect up to the CAN bus. So there's a couple of metal plates put in, and then the customer has to get the mechanic to fit those plates behind the vehicle headlights. So we'll see if that works. Obviously, physical preventions can be very, very effective. So we'll have to see.
So, are Toyota trolling us? This article was released a few weeks after our blog post. 2024 Toyota Tacoma gets a JBL sound system with nifty Bluetooth speaker. Here is a picture of said removable speaker. It would be quite funny if it had the additional electronics inside it that would be able to assist if you lost your keys out on the trail. We don't actually get these vehicles in the UK, so there'll be no chance in me actually getting one of these speakers to retrofit it just for laughs. So on to the fallout of some of our findings. David Rogers recently tweeted this: Direct Line are now no longer insuring any Land Rovers due to the theft problems. What will it take for the car industry to actually take security seriously? These issues are solvable, but yes, seems to be a bit of a crime spree going on with Range Rovers, etc. On to my final slide. I'd like to say thank you to the ASRG, specifically John Hildreth, for assisting in the disclosure process to Toyota and for allowing us to present today. I'd also like to thank BugCrowd for inviting me to the 2 bug bashes and all of the car hackers that were present at those events. I'm sure we've both learned from each other. I'd like to say thank you to Noel Loudon, the friend that is in forensics and the ex-police officer who pointed me in the direction of the device itself. Finally, I'd like to say thank you to Zoltan Wolner. He's my friend that has the Lexus. I didn't ask him to potentially break his own vehicle, but he did, and that helped our findings. Down the bottom there are details of both mine and Ken's website and contact details. If you have any questions, we will be around after if required.
Welcome back. Ian and Ken, thank you for the great presentation. Very insightful. And we are now in a very comfortable position. The time is over. However, we have a break of 20 minutes. So I do not want to end this session without a proper Q&A. So let's do it. We have a nice amount of unanswered questions, and I will just show them on stage and just go for it and answer them on the fly. You probably saw a few of them already because you followed the presentation. However, I love democracy. That's why I need to ask this question. What is your most favorite animal and why is it a tiger? So, it's of course an inside joke because at the backstage, Ian was holding a tiger, and Ken has a tiger on his sweater. It's a mascot, right? It's a mascot, Ian.
Yeah, it's a mascot for the car hacking village in the UK. He has his own Twitter. He can be a bit cheeky.
Perfect.
Follow him and/or me on Twitter. But yeah.
Thank you very much.
My kit car is also a Tiger Super Cat. So that's another tie into the Tiger.
Perfect. I will be. I just mark it as answered. Thank you very much, and I focus on the more technical questions. And the next one would be where the unlock and start engine signals simply replayed? Question mark.
Yeah, then there's not. It's not a cryptographic message or anything. So there's no. It's not like a replay attack. It's just yeah, they're fixed frames with payloads. With the signal bits within the payload just set to indicate the immobilizer is okay and authenticated now. So yeah, there's nothing very clever about the payloads apart from finding out which ones they are, which we haven't disclosed.
I understand.
The problem is with the immobilizer payload, you need the additional modified transceiver component for it to work. Otherwise, it does not work. Basically, it shuts that whole bus down.
Understand. Next question, and it starts with a greeting. Hello, would that be a correct solution if the headlight ECU is a separated CAN bus from smart key or doors open ECUs?
I think that's the gateway FAQ. It's not cost effective in any way. They're not going for the headlights because the headlights are something special. They're going for the headlights because it's the easiest way onto the pair of CAN bus twisted pair wires, and that bus runs all over the front of the car. And if you can punch a hole in the bodywork and get access to them, you can then put probes into the CAN bus wires and inject it like that. So even if you have a gateway, it doesn't fix the problem because it's the bus that counts, not the end point.
Gotcha. Next one from Mohammed. Does the CAN injection signal that you showed is basically they drive the voltage to a certain degree that it could allow the designated CAN frames to be accepted and transmitted?
Sort of. With CAN, the way it works is that the dominant state is an actively driven state. If you think about like an open collector transistor, kind of what a transceiver is. And so if you drive the voltages, then you're effectively pulling them apart, and then the receiving transceivers see that as the recessive bit. Sorry, as the dominant bit. So if you're driving a recessive bit, they normally would float back. So you stop driving it, and everything would float back to the recessive state. So by driving it actively, all the other transceivers that are leaving it effectively undriven, it will become driven to that voltage and won't be driven away from it, because you're effectively getting some multiple transistors across all of the ECUs to fight each other. Only the actively driven one will beat all the others. So it's not the voltage levels; it's the driving force behind the voltages.
Good. Then we have another one, and I skipped one question because that probably will be the last one for today. I take this one. Did you get your vehicle back, or just another one which looks suspiciously similar?
No, I did not get my vehicle back, and no, I do not plan on buying another Toyota until it is fixed. Yes.
Yeah.
But the vulnerability may be wider than just Toyota, because if you notice some of those vehicles, they are on other platforms. The Supra is basically a BMW Z4. Does that mean the BMW Z4 is also vulnerable? Maybe. The Pro Ace van is based on the PSA, or Stellantis now, UMP2 platform. If the Pro Ace van is vulnerable, the UMP2 platform may also be vulnerable. So we need to get in contact with these other vendors as well and say, by the way, you may want to check it. I also wouldn't mind checking other vehicles just to see whether it's leached across into other OEMs, but can't go into too much detail on that one.
So we have like 200 people online in the session. So maybe the one or other can establish a contact to those OEMs. If this is the case, just get in contact with Ian later on in the lounge. So that will be a possibility to ask even more questions. However, I would use 5 more minutes to use for other questions. Ian.
I will say that my communication with Toyota USA, we have subsequently disclosed the information to them over a back channel, not over HackerOne VDP process. They are currently looking into it and are going to get back to us at some point in the future. The discussions I had was actually at DEF CON. Just before I did the initial version of this talk at DEF CON for the Car Hacking Village. So they are now up to date. They have all the information that we have. Again, thank you to ASRG for trying to assist with the VDP process. But eventually, Toyota did make direct contact with us via DEF CON. So that's good. But it shouldn't have to take that amount of time and resource to do it. It should be, okay, I don't agree to your terms and conditions. Can there be a caveat here that we don't and we still communicate some way? That I understand why they need it via HackerOne, because they need to log it somewhere. But having those terms and conditions that basically says once you've told us you can't tell anyone else, sort of buggers things up for the whole industry potentially. Again, also Isaac could have got involved and said, can you come and speak to us and we can tell the industry what our findings are in very much detail. I don't really want to be telling random security company the finer details, because what are they going to do? Try and generate some solution to a problem they don't quite exist to try and sell some whizzy magic thing. I won't name the security vendor that did get in contact and try and do that, because I don't want to shame them. They're not present today, I don't think, but some random security company saying, oh, by the way, we want to discuss your stuff. Not going to happen, because I don't know you from Adam, and it's bigger than just this one company, we believe.
Understand. I think we have time for 2 more questions, and it is probably this one. During the reverse engineering, you mentioned about it being locked. How did it locked exactly? Can it be unlocked using any side channel attack?
The firmware itself in the PIC microcontroller is locked using the fuse bits. There is a Heart of Darkness attack that can be used to actually do it, but that would involve having two versions of the chip, because you have to read out the first half of the chip on the first try and then the second half of the chip on the second try. I have actually had an offer from a third-party chip manufacturer company's research department to say they could also try power glitching to do the same thing. We haven't taken them up with that at this time, because we don't think we need to. We've managed to get all of the data out of the device by listening to what it does, sending messages to see whether it responds accordingly to other messages and anything changes. It does not seem to do that. So I don't believe we actually need to do the full get the code out and reverse engineer it, because what we've found seems to be correct.
Good. Last but not least, and this is a little bit off topic. However, 3 people upvoted it, so I would like to show it on the stage. It's rather addressed. So Ian, you are rather addressed, and the rest of the questions you can address in the lounge later on. So the question is: I'm always interested in the vehicle in box you created. How you modify it to be like a real vehicle?
Good question. It's not as complicated as you think. If you look on my GitHub, github.com/mintinet, there is actually a repository called CAN Inje that actually has the software and sort of hardware files to actually do it. There are a few different ECU simulators in my CAN Inje. There's one for the ABS simulator, which is basically a motor that is controlled via pulse width modulation and listens to the CAN bus. And depending what message it gets from the CAN bus on the current speed, you can twist a potentiometer and make it go faster or slower. And there's a feedback loop that then listens to see whether it's going fast enough and then speeds the motor up. And then if it goes too fast, it will slow it back down again. So that's the first one of the simulators. There is a second simulator based on an Arduino Nano and a potentiometer that uses a bit of software called ArduStim, which basically fakes the crank and cam sensors. So if you know that it's a 60-1 on the back of the crankshaft and the specific wave shape from the crank sensor, you can program it accordingly with the right digital patterns for the for that ECU. There are other talks I have done previously on how I built my car in a box. If you search for me on YouTube or even ASRG, I have actually done that talk there. The third one of the simulators is an O2 simulator. And the O2 simulator is basically a pair of 555 timers. Because the O2 signal is a AC wave on a DC offset. So basically it goes lean, it goes rich, it goes lean, it goes rich, it goes lean, it goes rich. And as long as you're sending that back through to the actual car, it thinks the O2 sensor is working. There is one other part with the O2 sensor you also need to do is you have to put in a heater circuit, which generally consists of a very large 50-watt wire-wound resistor that burns 1 amp of power permanently. When in person, I always say, please don't touch it. It's around the back of this box because it will burn you. It gets hot when it's on for 4 hours a day or 8 hours a day. Numerous times I've had owie, I touched it. It's like, you're an idiot. I told you not to. But there are ways to fool sensors in a vehicle to think they are working. It's like a temperature sensor is a variable resistor. So put a potentiometer in. A fuel gauge is also a variable resistor. Put a potentiometer in. You have to play with some of the settings to make it appropriate for the value of the resistor it would normally use. So some of the common potentiometer values may be a bit big and you might have to play with it, but it does work. But then you have the ability on my car in the box to break out the internal CAN buses via extra OBD2 ports. And then you can plug in things like my disco mode. So disco mode basically fakes the CAN messages from the steering buttons very, very quickly and makes the lights and horn and washer bottle flash. So yes, it's a way of showing cause and effect. Again, if you want to get into car hacking, buy an instrument cluster and just fuzz the living crap out of it. You can send every message you can think of and see what it does. You're not going to break it. Don't put it back into a vehicle, because I did that on my car in a box. And my car in a box went from 44,000 miles to 1.2 million miles because I walked the bits all the way across from 1, 2, 4, 8, 65,000, 128,000, 250. Oh shit, 1 million. Yeah, don't do that. And definitely don't do that on your own car, because if you're on PCP finance and you jump the mileage, they will make you pay the difference. But if you need to get in contact for any of those bits of hardware, I have copies of the hardware available. If you want me to send them to you, I can put them in the post. It will just cost you postage.
Perfect. Ian, thank you very much for the comprehensive answer. Ian and Ken, thank you very much for this very interesting, insightful presentation, and see you in the lounge later on, right away, let's say. And because there are way more questions, as you see, and these needs to be discussed. So thanks and bye-bye.